Hey there, in this video we're talking about issues of strings and scope and styling in C++, and this covers sections 2.13 to 2.18 more or less in the Gaddis C++ book. So here we are at the end of chapter 2. This is our last discussion in that, and therefore we kind of get a grab bag of other issues that we should know about at this point. So 3 separate things in this video. Let's talk about strings. Right? In the last video, we were talking about the basic data types in C++, so the fundamental data types or primitive types or atomic types, depending on how you say that. And any other type of data that you ever see in C++ is going to be a compound data type that's built up from a combination of those things. And character strings are a great starting example of that. So a string is really a series of a whole bunch of characters in consecutive memory locations. Okay, like you might see this for a string literal, right? Double quote hello. How is that actually stored in the memory system? Okay, so obviously it includes all the characters between the double quotes that you wrote in your code. Those things are stored 1 byte at a time in memory, and then there's one additional byte at the end in memory called the null terminator, which is actually the value 0, indicated by the escape sequence \0. And that's how C++ knows that it's run into the end of a string. So here's what's actually saved in memory. 1 byte for the capital H, 1 byte for the lowercase e, 1 byte for L, another byte for another L, a byte for the O, and then 1 more byte for the null terminator. So you notice that I would say that this string has 5 letters in it, right? H-E-L-L-O. In order to store it, you have to use 6 bytes. Right? 5 bytes for the characters that you actually see, and then 1 more byte for the null terminator to tell C++ where the end of it is. Now, you might consider looking up in the ASCII table, like we were talking about last time, everything's a number. Technically, they were really storing numbers, right? So it might be interesting to look at exactly what numbers are technically being stored in memory in order to store the string hello. Let's actually do that. I'm going to pull up my mouse pointer as pen control. So on my other monitor, I'm actually looking at the ASCII table that's in the appendix at the end of the Gaddis book. So you might want to pull that up yourself to follow along here, or you could look at another ASCII table that you find online or something like that. So for what it's worth, the capital H actually gets stored as the number 72. The lowercase e is actually the number 101. Right? A lowercase l is the number 108. Obviously, we have 2 of those in the system. Lowercase o is number 111. And the null terminator is actually the number 0. Okay, that's kind of interesting. So a couple things about that. I'm writing these numbers in decimal format, which is our normal numbering system. A lot of programmers would prefer to see this in binary or hexadecimal format. It might actually be easier for them. That's something we'll talk about later on in this course. Second thing is notice that capital letters, right, have different encodings than lowercase letters. Our encoding is case sensitive. Capital H is a different character from lowercase h. If I wanted lowercase h, that would actually be number 104. On that point, notice that capital letters all have lower numbers than lowercase letters. To me, that seems a little bit unintuitive, but there's sort of a historical legacy reason why that's the case. And then finally, again, when we talk about the null terminator, that's actually the number 0. So when C++ is scanning a literal string and wants to know where the end of it, it's basically looking for the number 0 internally. So that's kind of interesting to kind of keep in the back of your head about exactly how character strings are stored. Now, everything we just said on the prior slide is true in both C++ for the string literals that you actually write in double quotes. That's totally how it's stored. And also the previous C language. Here we are in C++, and in an attempt to make some of that string handling easier, C++ has provided a more advanced fancy string class that gives you some additional possibilities. So when you want to declare a string data type, there actually is a type called string. So instead of int, float, char, or bool, you can make a variable of type string, which is kind of handy. So that's in the C++ standard library. It has been added on to the C language technically. this special data type specifically for working with strings. Now, technically, that's defined in the string header file, but at least for our purposes in Dev C++, the string header file itself is included in the IOStream file. So as long as you're including IOStream, you do have access to this automatically. So once that's available, you can define string type variables. Like I could declare string first name comma last name, and that's making two string variables, right? There's first name variable and there's the last name variable. Once you have that, you can start storing string values by assignment. So I could say first name equals double quote George and last name equals double quote Washington. And then of course you can start displaying those variables via count. So I could say count left arrow first name variable, left arrow, and probably I'd want to put in like a little space there, and then left arrow last name. And of course that would print out George space Washington on the screen. Great, so that's really handy. I'm glad that's in C++. Scope. So here's the second thing we wanted to talk about in this video at the end of chapter 2. So when we talk about scope, the scope of a variable is the part of the program in which the variable can be accessed. You know, programs get really, really long later on, and you don't want to have collisions between the many, many variables that you're going to be creating. So there's this idea of scope where the access location is fairly limited so it doesn't run into and cause problems with other variables. So just for starters, and there's a larger conversation of this, but just for starters, a variable cannot be used until after it's been defined, right? You have to declare the variable first, and then in that function, you can use it from that point lower on. Here's an example. So this right here is a program out of the book that is broken. It simply doesn't work. This program can't find its variable. So a mistake that sometimes beginning programmers make is I've got line 7 here where there's a count statement trying to print out this value variable, okay? But the declaration of value doesn't happen until later on in line 9, right? That's where int value is being declared and it's being initialized to the number 100, or at least you're trying to, because this isn't a legitimate C++ program and it won't compile. When the compiler is scanning this and gets down to line 7 and reads count value, it's going to say, I do not know what value is because I haven't seen a declaration for it yet. And you'll get that error, an undeclared identifier, and the thing won't compile and you'll have to fix this. So if I took that line 7 and just put it between lines 9 and 10, right, the declaration int value would happen first, and then you could legitimately access it in the printing line, the count line, and that would be an acceptable program, of course. So once you declare the variable, right, like the int value here, you do have access to it from that point down through the rest of that function. That's the scope of the variable. Now again, there's a larger story to this later on, but at least for now, when we're writing all of our code in the main function, that's the story. Okay, variables are accessible from the point where you declare them all down in the main function. Good enough for now. And the third thing that we wanted to get to in this video is, again, trying to be really cognizant about writing our programs in a style that is easy for other programmers to read. Remember, we're using these standard styling issues to make our code easy to read for other people, and everything that I'm saying here is basically standard among almost any kind of C++ programmer, so you're just trying to work on the same basis as your fellow coworkers. Here's a couple of bullet points here you should be aware of. Number 1, your comments should state goals of the next couple lines of code in proper English sentences, right? Your comments should start with a capital letter, right? Ideally, they're going to have punctuation at the end. Everything's going to be spelled properly. The comments are not just repeating code. I am not going to write a line like, here's a count statement with a string literal, and here's a sin statement with a variable, right? That stuff I can just see in the code itself. The point of the comment is to tell other programmers what is the goal of the next couple lines. We are getting user input for tax rate, right? That would be a good comment. You should align the statements in a block, and when I say block, the contents between two curly braces, like the body of the main function, all those statements should be aligned on the screen with matching indentation. And in this book and in this class, we are using a tab indent. Some people in the world like to use spaces, like they use 1, 2, 3, 4 spaces on the first line, 1, 2, 3, 4 spaces on the second line, right? And there's reasons why people want to do that. But in this class, we just want one tab to indent all the statements that are in the main function. Keep it lined up, and it's going to be very visually easy to spot what statements go together like that. You should keep your lines short enough to be fully visible on screen. You want as much information on screen as possible. You want everything about your function to be visible so people can just scan it with their eyes immediately. If you make a line super, super long, it's going to run off the end of the screen and people can't see what's over on the end there. Generally, we all say, let's limit our length to 80 characters maximum. And we know that other programmers, whether they have larger screens or smaller, depending on how their window's set up, 80 characters wide will definitely be visible for everybody nowadays, no matter how they've got their screen set up. There's actually a setting in Dev C++ that you can see the right-hand margin. It puts a little dashed line at the 80 character point, and you can kind of make sure you don't go across that dashed line. Might be handy. I always put spaces around any operator symbols like a plus or a times or an equals or a left arrow for the insertion element with a count statement. And that's just standard math writing. That's just standard program writing. If you look very carefully at any math book, if you look very carefully at any example in our C++ textbook, this is always the case. So I have a plus sign or some kind of symbol like that, and I put a space on either side of it to visually offset it and make it really visibly clear what things are being separated or what things are being connected. So try to get in that habit too. Now let's take a look at an example of the styling rules that we're following. Have a very short code file here on screen. First of all, at the top of every code file, there needs to be a comment header for our course. And this comment header is in the Dev C++ style. You can access that in Dev C++ by clicking on Insert Snippet Comment Header. And that gives you a template that you can fill in with the name of the program, copyright date, the author, which would be your name, the date that you're building it, and a very short description of what the program is supposed to do. So we expect that in that exact format there from Dev C++ at the top of every code file that you submit, so we know where it's coming from. 2, remember the pattern that we're in when we're writing our code is we write a blank line, a one-line comment, and then a couple lines of code. And then a blank line and a one-line comment and a couple lines of code. And we keep doing that for all of the code that's in the main function there. Remember that we have spaces around operators. So if you look closely at line 18 there, the insertion operators have a space right before it and a space right after it. If you look at lines 14 and 15, the equal signs, there's a space right before it and a space right after it. Again, we're doing that for the human readers to make it visually pop out. The compiler doesn't care whether there's a space there or not, but for human readers, this is how you write math, this is how you write coding, and it's been found to be easier for people to parse visually when we do that. Notice that on line 18, 19, that's actually just one single very long statement. And if we'd written it all on line 18, it would have run right off our screen and we wouldn't be able to visualize, we wouldn't be able to read what's on the far end of it. So in this particular case, it's clearly a lot longer than 80 characters or 80 columns. So what we've done here is we put a line break at the end of line 18 and permit some of the code of that one statement to be sitting on line 19 instead, so the whole thing can be sitting on screen within sight at once. Also note that if we do that kind of continuation line on line 19, we put one extra tab there to visually indicate that this is really part of one ongoing statement. The curly braces should be lined up one above the other. So if you look on line 12, that's got the open curly brace of the main function, and line 21, that's the closing curly brace that ends the main function. And they're directly one above the other. That's normal C++ style. That's what happens in every single example all through our textbook, so you should probably do that. Now, if you're familiar with Java style, they would put the open curly brace at the end of line 11 and actually save themselves one line of space on screen. And I can understand why they do that. In my course, I actually do accept if you style it either one of those ways. To be clear, official C++ style is to have the open, closing curly braces stacked directly above each other in order to be very, very clear about where the beginning and where the ending of the function is. And do remember that every single line in the main function is going to have one tab indent. Not a bunch of spaces, not several tabs, just one single tab character indent to indicate visually that all these statements work together. They're all part of the main function. And again, that's something that just pops out immediately visually. Clearly, these are all part of the same block. And that's what everybody does as far as indenting the statements in the main function. So you should definitely get in that habit. Now, as you're learning how to style your programs normally to help out your coworker programmers, as you're training your eyeballs to see code this way, Dev C++ has a couple tools to help you get started. Number one, that comment header at the top that we expect as part of all of our code files in our course. You can make that happen automatically in Dev C++ by clicking on the Edit menu and then Insert Snippet and then Comment Header, and you get the template for those 7 lines there, and you can fill in with the information about you and your program. So that's required for all the assignments in our course. And as far as the styling goes, there's a built-in tool that's called the Artistic Styler. You can click on A Style in the top toolbar for Artistic Styler, click on Format Current File, and that tool will try to fix up your curly braces and your indentations and things like that to put it in proper style. Now that's not everything. That's not everything that we're looking for in styling as far as how you use comments or how you use blank lines or spaces around operators or things like that. So later on in the course, we'll have another tool that will help you fine tune all that kind of stuff. But the Artistic Styler is a pretty good tool to begin with. Again, as you're just learning curly braces and indentations and things like that, feel free to use that to get started with. All right, one more thing here. Compiler settings. Any compiler setup has a number of optional switches for exactly how the compiler works as far as giving out errors or warnings. So you kind of want to look at this carefully. I tend to prefer to use stricter warning settings. We all agree as professional programmers, we all agree that it's preferable to find out about problems sooner rather than later. If you find out if there's a problem and it persists for a while, you're going to be building around it and building on top of it. And the day that you need to fix it, you're going to have a heck of a lot of work to fix whatever the issue is. If you find out about an error as soon as it happens, then you can fix it right then and you're not wasting time later trying to work around it. So I generally put very strict warning settings on my compiler settings so it will tell me about problems immediately when I first compile a thing. In particular, there's a switch called the pedantic switch, which we can turn on to enforce ISO, International Standards Organization, style C++ and make sure it conforms to that international standard, and the code that we write will work on any compiler or any environment. So here's what that looks like in Dev C++. I think this is under Tools, Compiler Options, right? Settings, there's the setting tabs here, and then I clicked on Warnings. And there's a couple different options you could turn yes or no to about how it looks like. The things, and by default, these all start off as no. It starts off very generous, and there's a whole lot of problems that it might allow to skate through that you wouldn't even know about. So personally, I turn on these 3 things to yes. I turn on yes to show most warnings, which technically is the W all flag, and I turn on yes to check International Standards Organization C, C++, C++ OX conformance. That's called the pedantic switch. And I also turn on the make all warnings into errors, right, the W error switch. There's a lot of possible problems in code that are called a warning, and if there's a warning, it'll still compile. So I find that beginning programmers will write a program, have a warning go by, ignore the warning, and then at the end of it have a program that's got a logic error in it. Like later on, they're going to get in trouble for some reason. Remember that logic errors are the thing that's hard to fix, right? It's an existing program, it's compiled and it runs, but the result at the end isn't correct. Logic errors are hard to fix. So I would prefer to turn the warnings into errors and have it not compile, and now I have a syntax error, and that's easy to know about and easy to fix. So that's why I turn on these warning settings fairly high, turn my warnings into errors to make sure that I don't overlook it. And I would recommend that you do the same thing. And before we're completely done with this chapter, I want to share what I consider to be the number one most important philosophical principle about computer science, and that's the don't repeat yourself principle. So don't repeat yourself, or DRY, dry for short, is a principle that any logical job should be done in only one dedicated piece of code. You should not be doing the same coding task multiple times in the same program. And if you can avoid doing that, there's so many benefits to it. Your program is going to be faster to write because there's less code. It's going to be shorter for you or other people to read later on because the program's shorter, which we like. There's going to be fewer bugs because less code means less opportunities to make mistakes. And if there are bugs for some reason, it's going to be easier to fix because you only need to fix it in one place, not hunt down all the times you made the same mistake because you were repeating code. So many benefits. And if we take a step back and we kind of take the big picture and think about why are computers in the world in the first place, well, computers were invented specifically to do repetitive tasks like complicated computations, specifically so that people don't have to do it anymore. So in the modern world, you might argue people should not be doing repetitive tasks because we have computers and that's what they're for. So if you're using a computer, maybe you're writing a program, maybe you're doing something else, and you find yourself basically typing the same thing over and over and over again, as a computing professional, you really got to stop, take a step back and think, is there a better way? Is there a better way that I can use the computer itself to do this repetitive task and make my work shorter? So important. Now, that's not something I came up with. That comes from a very famous book by Hunt and Thomas called The Pragmatic Programmer. And if you ask most any professional programmer about the don't repeat yourself principle, they'll almost certainly know what you're talking about. So again, for me, that's the number one philosophical principle about computer science. We're going to keep coming back to this. We'll talk about this day after day after day, all through this course and probably other courses as well. And we'll think about every time we introduce a new feature in C++, the whole point is to make our work go more quickly, to avoid repetitions of something that we used to have to kind of do over and over again. And really every single feature in our high-level language like C++, that's really the point. Okay, so that's chapter 2. And in this video, we looked at, again, kind of a grab bag of strings and variable scope and styling issues. And we'll probably talk about more on all of these things in later lectures, actually, but there's kind of the basics of what we need to get started with in the first 2 weeks or so of our Starter C++ course. So for students in my class, at the end of every chapter, I always ask them to do these things for homework. They should read the book chapter 1 and 2 at this point. And I usually say, if you're going to get an A in the course, you should actually read the book chapters to get more details that we didn't have time to talk about in our lecture sessions. Then every chapter of the Gaddis book has a nice section of review questions. And in particular, I point people to the fill-in-the-blank questions to kind of test themselves with. It's very similar to at least one section on the tests that I give. In my course on our learning management system, there is an appendix to the book that comes digitally. It's Appendix M, and that has all the answers to the odd-numbered review questions, so my students can check themselves with that. And at this point, I would always assign a programming challenge out of the book from chapter 2, and my students should look on the learning management system to see exactly what that is, and there's some notes there to be careful about. And that's a good thing to exercise at this point in the course. Finally, the next time that we'd be in person, we do this lab 2.4 probably on characters and strings. And so this is a good exercise in everything we've talked about recently. You get to practice using characters and strings and variables and constants and literals of various types of data and storing and printing out all those different kinds of things. So that's pretty good coverage of stuff that we've talked about recently. So I'll look forward to looking at that. Now, in the next video, when we come back, we're going to start in on chapter 3, and there we will start to actually use the SYN statement for interaction, getting user input into our programs for the first time. And we also need to look more at the details of mathematical expressions, because of course, Computers are for computing, so math is one of the most fundamental things that it does, and we should understand kind of clearly about exactly how to write our mathematical expressions. But that is next time, and I'll look forward to seeing you then for that.